continue with the explanation. We were doing this slide. Now sodium metal, it is highly reactive, as I told you. Okay, so what is happening if you keep sodium metal in the open? Okay, that means if it is exposed to oxygen and water, it will react very fast, and in that process even fire can come out from that piece of sodium. Okay, suppose you have a piece of sodium and you keep it in the open. Suddenly after a few minutes you will find that fire coming out from that piece of sodium. It is so reactive. That is why sodium is always stored in kerosene. Okay, so if you keep the metal in kerosene, then it will be, it will remain cool, okay, and a lot of heat will not be liberated. Okay, now again activity 4.5 is also not needed. Okay, so please don't study. Now sodium reacts vigorously with water. Some other metals do not do so. For example, iron reacts with water slowly. So different metals, they react with water in a different way. Now sodium, it reacts very fast. Even fire can come out of sodium. But some other metals are there, like iron. Iron reacts very slowly with water. Okay. Generally, non-metals do not react with water, though they may be very reactive in air. So non-metals, they do not react with water. They generally react with air. Okay. Such non-metals are stored in water because they don't react with water. Now sodium, it reacts with oxygen and water. So you cannot store sodium in water. Okay, you cannot store it in the open also because it will catch fire. Okay, because it reacts with oxygen. So where you have to store? You have to store it in kerosene. Now non-metals, they react with air. They don't react with water. So because they don't react with water, you can store it in water. For example, phosphorus is a very reactive non-metal. It catches fire if exposed to air. So if you keep phosphorus in the open, like if you keep sodium in the open, it catches fire. Similarly, if you keep phosphorus in the open, it catches fire. So where you can keep phosphorus, you can keep it in water. Okay, why? Because it doesn't react with water. Because phosphorus is a non-metal and non-metals do not react with water. So you can keep phosphorus in water. Okay. Now reaction with acids, activity 4.6 is also not needed. So please cross it in your textbook. Non-metals generally do not react with acids, but metals react with acids. Okay, so all metals, they react with acids. All non-metals, they do not react with acids. So metals react with acids, and what is produced in the reaction? Hydrogen gas. Okay, so when hydrogen gas is produced in the reaction, you will hear a pop sound if you bring a burning matchstick. Suppose you are performing a reaction in a beaker. Okay, suppose you take any metal, suppose you take sodium metal and you put hydrochloric acid over it, any acid over it, then what will happen? In that reaction, hydrogen gas is given out. And you know hydrogen gas, it makes the matchstick burn with a pop sound. So once you bring a burning matchstick near the beaker, you will immediately hear a pop sound coming out from the reaction. Okay. So copper does not react with dilute hydrochloric acid even on heating, but it reacts with sulfuric acid. So some metals, like copper is a metal. Now hydrochloric acid is also acid, sulfuric acid is also a acid. But copper does not react with hydrochloric acid, but it reacts with sulfuric acid. Okay, and remember, metals react with acids to produce what? To produce hydrogen gas. And how hydrogen gas burns? It burns with a pop sound. Okay, so this, it is not possible for me to show you now because, but still I will see if I can find some YouTube video I'll give you, because this actually I show the students in the lab. But since now it's not possible for you to or me to access the lab, but I'll search for some YouTube videos and I'll show you that how hydrogen gas burns with a pop sound. Okay, yeah. Now reaction with bases, again 4.7 activity is not needed, so you cross it. Metals react with sodium hydroxide to produce hydrogen gas. Okay, so metals, sodium hydroxide is a base, NaOH. Okay, the formula of sodium hydroxide is NaOH. You can Google up and see also. So what does it produce? It produces hydrogen gas. Okay. Remember, so metals react with acids also to produce hydrogen gas, and metals react with bases also to produce hydrogen gas. Now reactions of non-metals with bases are complex, so it is not needed. So you just remember, a question can come, how do metals react with bases. You have to write metals react with bases to produce hydrogen gas. Okay. So now we come to displacement reaction, a very important part of the chapter. Recall the activity of reaction between copper sulfate and iron that you performed in class 7. Do you remember one reaction we had done? Blue vitriol and green vitriol in class 7. Last year, physical and chemical changes. There we had done blue vitriol and green vitriol. Okay. So if you remember, iron when it reacts with copper sulfate was blue vitriol. What do you get? Iron sulfate and copper. Iron sulfate is green vitriol. Okay, if you remember. So this reaction is a displacement reaction. Why displacement? What is displacing? Displacing means when you take someone's place. That is called displace. Okay. Suppose you were sitting on the chair and I went and sat on that chair. That means I took your place. Okay. That means I have displaced you. Got it? So displacement means when you take someone else's place. That is called displacement. Okay. Now if you look at this reaction carefully, iron is reacting with copper sulfate. Iron sulfate is formed how? This iron has taken the place of copper. Yes or no? Iron has taken the place of copper and it has formed iron sulfate and copper is released. Can you see? So these type of reactions are called displacement reactions. When one metal will take the place of some other metal and it will form a new substance. Like here, iron has taken the place of copper and has formed iron sulfate, which is a new substance. Okay, so these type of reactions are called displacement reactions. Okay. Now, displacement reaction is a reaction in which one metal displaces another metal from its compound in aqueous solution. Okay, aqueous solution means this copper sulfate is in the form of solution. Okay, that is why it is called aqueous solution. One metal displaces the other metal from its salt. Now, copper sulfate is a salt which is dissolved in water. Okay, so it is an aqueous solution. If you remember, it was a solution. Okay, so this iron is displacing copper from the aqueous solution of copper sulfate. Okay, so it is called displacement reaction. So in beaker A I have taken from that activity. That activity is not needed, but the theory part is needed. Okay, because this is important. Zinc replaces copper from copper sulfate. Now you see this reaction. Zinc formula is Zn. Copper sulfate formula is CuSO4. What is formed? Zinc sulfate. That means zinc has displaced copper from copper sulfate and it has formed zinc sulfate. Am I clear? Zinc has displaced copper from copper sulfate and has formed what? Zinc sulfate. Okay, and copper is released. Okay, it is deposited in the beaker. Okay, so that is why blue color of copper sulfate disappears. If you remember in this reaction also, the blue color of copper sulfate has disappeared and iron sulfate was green in color. Similarly, in this reaction also, this copper sulfate is blue. So this blue color of copper sulfate will be disappearing and zinc sulfate is colorless. Okay, so it will form a colorless solution. Okay, understood? So activity 4.8 is not needed. So I have taken this from activity 4.8, but you need to understand the reaction theoretically. Okay, so we'll continue with the explanation in the next slides. Thank you.